All right, in this lesson, I want us to talk about sigma notation. Okay, so in this concept, we're going to have a sign like this. Okay, so this sign represent is the sigma notation. Okay, and basically this sign, what it means is just saying calculate the sum. Remember, we're having a notation for sum, but now we have integrated it to sigma notation. Okay, so when you see this, you see sigma, and in mind you must know that you have to calculate the sum. Okay, so we have to calculate the sum from term number 1 or term number 0 or term number 3, whatever it's in the bottom, it's showing you that you must start from there when you calculate your sum. And then whatever it's on the top of this sign, it will be the number of terms of that particular series. Okay, and then in front of this sign you will be given the general formula, the Tn for that particular series. Okay, so one thing you should know, or the three things you should know when you are given a sigma notation, sometimes you'll be given this. Okay, and then they just say evaluate. When you have to evaluate this, the first thing that you have to do is to expand your formula. Okay, or to find at least find the three terms of the sequence. Okay, and also the second thing that you should do is to find the ratio or the difference. Okay, and then this one will depend because of the sequence that you'll be given here. Okay, if it's an arithmetic, it means you're going to find the difference of the terms, and then if it's a geometric one, you have to find the ratio there. Okay, then the third thing that you should do is to find the sum. Then you find the sum. Okay, so this is just a three process thing. Okay, so suppose that you are given this example here. Okay, so here is our example. Then they say to you evaluate this problem. Okay, so you are given the sigma notation here. They say t starts from 1, and then you are given the number of terms on top of this sigma here. It's 20 terms. Okay, then here you are having your general term. Okay, so when we say you must expand this, or at least find the first three terms, it means you are going to start from 1. Okay, where you see t, you're going to substitute 1 to form a pattern. Okay, so it means you are starting from 1. Okay, this is your term number 1, and then it means here you're going to put 2 for term number 2, and then here you're going to put 3 for term number 3. Okay, so when you punch this in your calculator, 3 multiplied by 1 is 3 minus 1, and then you get 2, and then plus, then this is 6 minus 1, and then you get 5, then plus your third term, it's 9 minus 1, which is 8, and then it goes to the 20th term. Okay, so if you have at least 3 terms, then you can see how the pattern changes. So from these 3 terms, you can see that we are dealing with an arithmetic series. Okay, so it means now we can check for our d value, our difference here. You can see that to move from this term to this term, we add 3, even from this term to this term, we add 3. So it means the difference from or between any two consecutive terms, it's what? It's 3. Okay, so we find our difference here. Then now we can calculate the sum. And then because you are dealing with an arithmetic series, so it means you are going to use the sum formula for the arithmetic series. Okay, so that formula says Sn is equals to n over 2, then 2a plus into n minus 1 multiplied by difference. Okay, so we already know our a value, which is the first term, it's 2. We have our difference, which is 3, and then what about our n? Okay, so to find n, okay, this is very important. To find n, we say n is equals to top minus bottom plus 1. Okay, when we say top minus bottom, if you can check on this sigma sign, okay, this sigma has the bottom part whereby it says t is equals to 1, and then on top of it, it has the number of terms. Okay, sometimes it might be tricky that t doesn't start from 1, and then you have to calculate the number of terms, whereby here on top it's still 20, but it doesn't start from 1. Then things become complicated there. So always when you calculate your sum, make sure that when you find your n, you say top minus bottom plus 1. So what's on the top of this sign? It's 20. Then it means you're going to say this is 20. Then the bottom of it, it starts from 1. Okay, so you're going to say minus 1 plus 1. Okay, so this will give you 20. So it means the number of terms, or the sum, we're calculating the sum of the first 20 terms. Okay, so now it means you're calculating the sum of 20 terms. Then we're going to say 20 divided by 2 into 2. Then the first term is 2. Then it means you're going to have 2 multiplied by 2. Then our n value is 20 minus 1. Our difference, or our d value, is 3. Okay, you can choose to simplify this, or you can punch your calculator straight to get the answer. Okay, so when we simplify it, going to have 10. Okay, then inside here we're going to have 4 plus 19 multiplied by 3. And then when you work out that, you'll get your sum to be 610. And then you have evaluated this problem. Okay, I hope it doesn't complicate you, and I hope it makes sense. Okay, so I think we can check another example so that we can strengthen our knowledge on this sigma notation concept. All right, here is our example. We're given this sigma notation. Here it says the sum of 13 terms from 1, whereby the general formula is 3 raised to exponent k minus 5. So remember, we have to calculate the sum. Okay, so we must expand, or at least find 3 first terms of this sequence. Okay, so what we do is that we are going to substitute 1 here, or whatever value that you find here, you're going to start by it. If we were given 3, we were going to start by 3, then 4, 5, 6 going forward. Okay, so in this case we are starting with 1. Okay, so it means to find our first 3 terms, we're going to say this is 3 raised to exponent 1 minus 5. Okay, then this is 3. Because we are moving now, we're going to put 2 here minus 5. Okay, and then 3 minus 5. Okay, so now when you work with this on your calculator, you're going to get this is 1 over 81. Okay, plus, the reason I'm putting this plus is because this sigma notation is showing us that we must calculate the sum. So to calculate the sum, it means you are working with what? With a series. Okay, the semicolons here, I'm just using them to show that this is my term number 1, this is term number 2, this is term number 3, so that I don't confuse myself. Okay, so when you deal with this one, the second one, we're going to have 1 over 27, then plus, then the third one is going to be 1 over 9. Okay, so now we have to check the kind of pattern that we're dealing with. Okay, so by the looks of things, you can see that you can not have a common difference here. Rather, we're having what? A common ratio. Okay, so our common ratio in this case means R is equals to T2 divided by T1. Okay, so we're going to have 1 over 27 divided by 1 over 81. Okay, then when you solve this, you're going to have your R value to be 3. Okay, so we expanded, and then now we have our common ratio. Then it means we must calculate the what? The sum. Okay, and then we're going to use the sum formula for what? For the geometric series. So then the formula is that Sn is equals to A into 1 minus R raised to exponent n divided by 1 minus R. Okay, so the most important things here is that we must find the A value. And then our A value is the first term, which is 1 over 81. And then our R value, we have it, which is 3. Okay, so our N value, okay, our N value, remember it's top minus bottom plus 1. Okay, so what's on top of the sigma notation is 13. Then what's on the bottom is 1. So it means we're going to have 13 minus 1 plus 1, which gives you 13 terms. So we are dealing with 13 terms. So we're calculating the sum of the first 13 terms. So it means we are going to have S13 is equals to our A value. It's 1 over 81 into 1 minus R value, it's 3 raised to exponent 13. Then all divided by 1 minus 3. And then when you get your calculator, you will get that your final answer is 79. Okay, 7161 divided by 81. So this is our sum. So it means this is equals to that answer that we got there, 797161 divided by 81. So it means the sum of this geometric series of 13 terms is equals to this value. Okay, I hope it doesn't confuse you. All right, here's our next example. It says consider the geometric series whereby the sum to infinity, okay, and then we are given that this is equals to 27. So the sum to infinity of this Tn is equals to 27. Okay, and the sum of the first 3 terms is equals to 26. And then they say calculate the value of the constant ratio R of this series. Okay, so now we have to deal with this piece by piece so that we can understand this question and answer it correctly. Ne? So what the question is looking for is the value of R, but we are given the sum to infinity of a geometric series, and they say it's equals to 27. So this sigma notation, we know that when we see this, it's like we're having this is the sum to infinity. Okay, so this is equals to 27. Okay, so what is sum to infinity? We know that sum to infinity is equals to A over 1 minus R, and we know that this is equals to 27. So it means 27 is equals to A over 1 minus R. Okay, so this is the information that we have, and we have analyzed from the statement. Okay, and then they say to you the sum of 3 terms is equals to 26. Okay, so remember, how do we get how do we calculate the sum of values, not sum to infinity? The sum formula for geometric is saying Sn is equals to A into 1 minus R raised to exponent n divided by 1 minus R. Okay, so we know that the sum of 3 terms, it means where we see n, we're going to substitute 3. Then it means this is 1 minus R raised to exponent 3, then over 1 minus R. And then we know that this is equals to 26. 26 is equals to A into 1 minus R cube over 1 minus R. So we are having 2 equations here. This is our equation 1, and then this is your equation 2. Okay, remember we are looking for what? The constant ratio, the value of r. Here we were analyzing the question, so we can see that we are going to have to deal with simultaneous here. Okay, so we can take equation 1. Okay, we can say from equation 1, okay, our equation 1 is 27 is equals to a over 1 minus r. Okay, we can make a the subject of the formula by multiplying both sides by 1 over r, or by multiplying with our denominator. So it means our a value, okay, it means we're going to have 27 into 1 minus r is equals to a. Then we can name this to be equation 3. And then we substitute equation 3 into equation 2. Okay, so our equation 2 says 26 is equals to a into 1 minus r cube divided by 1 minus r. So it means where we see a, we are going to substitute a by what? 27 into 1 minus r. Okay, so this goes to be 26 is equals to, our a value is 27 into 1 minus r, and then which is we're having 1 minus r cube, okay, divided by 1 minus r. Okay, so now we have to deal with maths. So we can see that we're having multiplications on the numerator. Okay, so this one can divide this one. Okay, now we are remaining with 26 is equals to 27 into 1 minus r cube. Okay, when solving this, we can divide both sides by 27. Okay, so it means we can divide this by 27, divide this by 27. So it means you are having 26 over 27, which is equals to 1 minus r cube. Okay, so we can further take this one to the other side, and then it means we're going 26 over 27 minus 1, which is equals to minus r cube. Okay, so from here you can punch your calculator. Okay, when you punch your calculator, you're going to have negative 1 over 27. Okay, negative 1 over 27, which is equals to negative r cube. When we divide both sides by negative, it means everything becomes positive. We're going to have 1 over 27 is equals to r cube. Okay, so to find the value of r, we must take the cube root of each term here. So it means I take the cube root of here, and I take the cube root. Then our r value becomes plus or minus 1 over 3. So it means your r can be positive 1 over 3 or negative 1 over 3. And then that way you have answered your question. Okay, so we can look at this example here. Okay, so you are given the sum to infinity of this formula, whereby this formula you are given by 6m raised to exponent k minus 1, and then they're saying this is equals to 12. So it means again the sum to infinity is equals to 12. This is what this whole expression on the left is saying. Okay, so the sum to infinity is equals to 12. Okay, they say they want you to determine the value of m. Remember, when we are given this, okay, you have to expand and form at least 3 terms, then so that you can find the difference and everything. So but now we know that the sum to infinity only applies to geometric series which are converging. Okay, so here we know that we're dealing with what? Geometric series. Okay, so to find the first term there, it means you're going to have 6m 1 minus 1, and then we're going to have 6 to the power 0, and then any number to the power 0, it's 1, then it's 6 multiplied by 1, and then it becomes 6. Then the second term, 6 into m, then 2 minus 1, it means we're going to have 6m. Okay, then for the third term, 6 into m, 3 minus 1 there is the exponent, and then we're going to have 6m squared. Okay, so to find the value of r, it means we're going to say t2 divided by t1, and then we're going to have 6m divided by your t1, which is 6, and then 6 divides 6, and then your r value becomes m. Okay, so r is equals to m. Okay, so the sum to infinity is equals to 12. So we know the formula for the sum to infinity. It says sum to infinity is equals to a over 1 minus r, and we know that this expression is equals to 12. Okay, in this way. So our a value, the first term, it's 6. Okay, so it means we're going to have 6 divided by 1 minus our r value, which is m. So this is equals to 12. Okay, so here we just have to do algebra, then we multiply both sides by 1 minus m. So here we're going to remain with 6 is equals to, then here it means we're going to have 12 into 1 minus m. Okay, then this multiplied by this, it gives you 12 minus 12m. Okay, so I can take this 12 to the other side, then I'm going to remain with negative 6, which is equals to negative 12m. Then dividing both sides by negative 12, divide both sides by negative 12, negative divided by negative, it's positive. Then our m value becomes 1 over 2. Okay, which is 0.5. It's equivalent to 0.5. Okay, so it means this is your m value, which is your r. It means our r in this case is what? It's 1 over 2. Okay, and remember, I told you that when you see the sum to infinity, you must know that this is a convergent sequence or a convergent series, whereby we know that when a series or a sequence converges, r should lie between negative 1 and 1. And in this case, you can see that 0.5 lies between negative 1 and 1. So this is the sigma notation and its application. So if you have any inquiry, my email will be on the description of this video, and if you don't understand anything, you can comment and then we can chat. So from me to you, bye bye, see you in the next one.